All right, hello everyone. Welcome to another episode of Courtcast. This is your host Tim.
And I'm Mikey.
And I'm Sahil, everybody. So welcome everybody to another exciting episode of Quirkcast. So before we get to it, I just want to mention a few logistical things. If you're watching on YouTube, please put your comments or questions in the channel, and we'll read them out and discuss. So without further ado, last time we had talked about dark matter in terms of like just does it exist and whatnot. And you had mentioned, both Tim and Mike, you had both had mentioned it's very difficult to detect what it is. So what I guess the thing we didn't discuss is like what can it possibly be? Like what do people think it is? Is it like smaller turtles on the backs of like smaller dark turtles and just turtles all the way down? Or what do you think, Mikey? I'll start with you.
I think it's a lot of like turtles next to each other, personally. It's like stacked like horizontally, yeah, horizontal arrangement, a lattice of turtles. Yeah, so I guess to review, to review, there's this stuff in our universe called dark matter. It's called dark because it doesn't interact with light, unlike all of the other kinds of things that we interact with. Like the reason I can see this couch is because light bounces off that couch into my eyes. The reason we can see stars is because they emit light and we can collect that light into our telescopes. The reason why my hand doesn't go through the couch when I touch it is because my hand and the couch are actually exchanging light particles, and that creates a repulsive force that we call electromagnetism, which is what keeps objects from going through each other, the repulsive force. But a huge number of astronomical observations combined with a huge number of theoretical calculations indicate that there's a huge amount of stuff in our universe that simply doesn't interact with light. So that means this stuff, which we have argued it does exist, would pass through us as though like it was like a ghost or something. So what is this stuff? We kind of stopped at the last episode because we were physicists are kind of at a complete loss to explain not only what it is but what its origin could have been, and these two things are kind of tightly connected. But if you're asking for me what my personal favorite guess on what dark matter could be is I think dark matter is complicated. I think it's probably more complicated than we think. Right now, when physicists think about dark matter, they always imagine it as just some blob of stuff. Because if we don't know what it is, then it might as well, for now at least, for all intents and purposes, be like a blob of dust. And what are the characteristics of this blob? But yeah, we'll get into it more later. I don't know, Tim. Do you have any thoughts? I think.
Yeah. So I think we should lay down some ground rules first.
Yes.
Like so it's kind of like we imagine we're playing this game. It's kind of like a hide and seek. So what could dark matter be? The job of a theorist is to propose some possibility, and the job of the experimentalist is to shut it down. So basically, the ground rules of what dark matter could be, first of all, is that dark matter has to be, it has to have the right properties, such that it can cook up the kind of structure that we see in our universe. Otherwise, it's kind of useless, right? Like we want dark matter to have the right, what people call relic abundance. It's just that we need to have the right amount of dark matter. That's first of all, and of course it has to be dark. And then the second of all, we have to play this game. Dark matter has to have properties such that we have not seen it yet. And as the audience might guess, this leaves a huge possibility.
Yeah. So Tim, I kind of want to ask you offline. Do you happen to know how machos are ruled out?
Yeah, we can talk about it later. I need to think about it a little deeper. The literature is not so
I think
straightforward.
that's the first guess, right? So if someone tells you that there's a bunch of stuff in this universe that seems invisible, that you can't see, you might be a little skeptical if I tell you that, oh, there's a stuff out there that doesn't interact with light. even though everything we know and are familiar with does interact with light. There's just this mysterious substance. You might just say, oh, maybe there's a bunch of stuff out there you just haven't detected, like planets or rocks or stuff swirling around. Maybe that stuff is just, you haven't measured it because you're not good enough at measuring stuff, and maybe you just think that there's extra stuff out there. It's usually by the name of macho, massive. Oh, shoot, I should have tried to.
It's like basically planets. Like imagine what if you have some planets you just couldn't see, like just normal matter. Right?
Yeah, or like stars that didn't ignite, or any kind of idea like that.
Yeah. So those are so ordinary matter definitively do not work because they're too clumpy. The one thing about ordinary matter is that it's dissipative. So basically, when we form atoms, like an electron crashing into an atom, it loses energy. So so when that happens, so you imagine this happening kind of in a galactic scale, right? When dark matter comes together, if it loses energy, it gets more clumped together. So imagine particles flying around. As it loses energy, it spirals in closer and closer. So that kind of matter is too clumpy. It forms like really clumpy planets, stars, and the way we need dark matter to be is it has to be kind of slightly more amorphous. It cannot have that much structure.
It's very fuzzy, right?
Yeah. So the second best thing is people thought about maybe like what if these are black holes? Like what if these are black holes that we just couldn't see them, so they're so black? And unfortunately, those are also ruled out because largely ruled out because black holes will cause light to bend around them. I think and this is called gravitational lensing. And we have some experimental data to see. I believe, is it like dwarf galaxies or something like that? That it cannot be that clumpy. Yeah.
I feel like you just said something very interesting that we didn't get to talk about, and now you're going into something else.
Yeah. So basically, that doesn't work.
Yeah. How do you feel about the macho thing? I mean, that's kind of like, is that a hard pill to swallow? Like the idea that could dark matter be some dark stuff out there that we haven't seen?
Like ordinary, like normal stuff, but we haven't seen it, like normal matter.
We're telling you that it can't be because normal matter clumps together too much, and when you observe dark matter, like there's usually like a little ball of regular matter and like this kind of amorphous fuzz of dark matter surrounding it. Yeah. So dark matter doesn't seem to clump into like these tight little spheres the same way that regular matter does.
Yeah, pretty much. Yeah, and you can roughly measure like what we call the halo profile, like around a galaxy, like roughly how amorphous dark matter is. And generally it's very amorphous. It's kind of like a blob. There's not too much substructure. So that's sort of the first rule.
We haven't measured the substructure of that well, have we?
We have not.
What is the substructure that you guys are talking about?
So if you look at a galaxy, typically if you try to measure the dark matter, you see like little luminous galaxies in the middle, and you see like this kind of like much larger swath of dark matter around it. And the idea is, could this swath have like little clumps of its own, little like streams going through it? Because dark matter probably interacts at least in some normal ways under gravity, and so it's likely that it's not just this exactly spherical halo that people think about it. It probably has some, at least streams, some overdensities, underdensities, and so people try to measure these structures.
Yeah, it's kind of nice to imagine it's like vegetable soup. So a galaxy is a very rich soup, right? It's got little chunks of things, stars and planets and dust and whatnot.
Rocks.
Yeah, but dark matter is more like it's a very creamy, smooth kind of soup. But to some extent, it's possible to have chunkiness, but that chunkiness, it cannot be like all of it. It could be like 10% chunky, maybe 5% chunky, but it cannot be 100% chunky.
Unless there's like 20 different kinds of chunks that don't talk to each other, then it can be chunky.
Yeah.
Which is not that unlikely, because there's how much more dark matter than regular matter? It's like, a factor of like 6 or 7. So there could at least be that many completely disparate chunks, and if you can't see any of the chunks, then it just looks like a creamy soup.
Wait, what? Why? Could you explain that a little bit more? Why is it if they don't interact, do you get this kind of like, is it the same thing as if it's just a few chunks, but of the same type?
Yeah, right. So like, we mentioned at the beginning that like regular matter likes to clump into these tight spheres, but it seems like dark matter doesn't quite like to do that. It seems like it likes to stay more amorphous. But I guess one of the biggest evidence for this actually is that galaxies tend to, as they evolve, tend to evolve into a disk-like shape. And very distinctly measure that galaxies have a disk-like shape and the dark matter around it is spherical. That's one of the evidences for the fact that regular matter likes to clump up in this way, and dark matter is sort of like more diffuse. Yeah.
Yeah.
But some theories say that, if dark matter, let's say, so if dark matter is just made up of one thing, it can't be similar to our matter because it would have disked up, so to speak.
Oh.
But if dark matter is made up of like 100 different things, and none of them talk to each other, then each of those disks would sort of evolve independently, and you might get something that looks kind of like a sphere, and it might be possible that this kind of structure is like, it's almost like we've ruled out like the next to simplest structure, but if you make the structure complicated enough, then none of the experiments really rule it out.
Yeah, but I guess we should first cover sort of the simplest first guess.
Oh, yeah.
So, and this is sort of a bit historical as well. Like, imagine you're presented with this puzzle with some extra stuff in the universe. Like, what is the simplest thing that could explain it? And even then, there are a few good candidates, in fact, already.
Yeah, machos were ruled out. The idea that dark matter could be like regular stuff, that was ruled out early, right? Like 40s,
yeah. That was very much early. People figured out that that doesn't work, right?
Yeah.
So the next best thing, so the next best and simplest thing is what we call the WIMP scenario. It's weakly interacting massive particle. It's basically that the idea is that there are these extra particles that are dark, that don't talk to light, so they're weakly interacting, right? And the reason we have not seen them is because they're kind of heavy to some extent, because if they're light enough, maybe we would have created them in collider experiments, or maybe, and there's also this relationship, the lighter, because we only care about dark matter to the extent that it has the right amount of total mass, basically, in the universe. So the more heavy dark matter is individually for each per particle, the less dense it is, right? So imagine, let's say I have like 100 units of dark matter in terms of mass on Earth, right? If dark matter is 10 times as heavy, then the density would be 10 times more dilute, right? So basically, this is the reason to consider heavier dark matter, is because if dark matter is heavier, that will explain why we have not been able to detect them. It's because there just aren't that many dark matter to begin with, so the experiments haven't seen them yet, because we haven't had enough dark matter particles passing through us. So basically, one of the simplest explanations of dark matter is just really heavy particles that don't interact with us very much, and they're just there.
One question I have to kind of go back to the original thing is, could you explain like why sort of to zeroth order, the model of dark matter would just be these galaxies that spin around in a flat plane, and then you have this spherical halo? Like, why would you expect it to be spherical if you can't see it? Like, what tells you that it should be spherical to begin with if you can't actually observe it?
Comes from measurements. Yeah, there's no reason a priori to think that it should be spherical. That comes from direct actually, Tim, you probably know more about this than me, right? Astrophysical measurements and.
Yeah. So one of the ways to measure it is to just how fast the galaxies are moving, and also there's a bit of theoretical input as well. So from the state,
that's the shape. The shape doesn't affect. I mean,
the shape.
The fact that it's not a disk.
Yeah, I don't know the details. Probably gravitational lensing will tell you a
Probably
little bit
lensing.
anyway. And
Yeah,
also, it's not like theoretically, if you have dark matter that's not dissipative, it will naturally form a sphere. There's no reason for it to form a disk.
that's a theoretical thing though. But I mean, there's strong experimental evidence also that the shape is spherical, right?
I think the radial profile has been measured. I don't know about the angular profile. I
Oh, it
know,
has to.
yeah,
We know it's not disk.
yeah. I mean, yeah. There just is no way for dark matter, if it's not dissipative, to create a disk. Like the theories just
Oh,
don't work out right.
that's a theoretical argument, though. I know there's experimental evidence that dark matter is
There
not this.
probably is, but I know the way they measured it is they measure the velocity distribution of stars in the galaxy or
Hmm.
No, but that could be a dark matter that's a well-aligned disk could also produce that. It's got to be lensing. It's got to be gravitational lensing.
yeah. So
Uh,
so I'm
we
not
get
familiar
we
with
can yeah we can move forward. We don't have to spend much time on this if you guys
Oh,
aren't aware. Yeah. Yeah. All right. So I guess my question is now we've explained kind of where this non-disk structure comes from dark matter. It's more of a like a to zeroth order spherical halo. And then you were about to say what you were going to say next, Mikey.
Oh, me? No.
Yeah.
Tim was talking about something, and then I stopped him because
yeah. So I guess we were talking about the simplest model are called WIMPs. So it's just that dark matter is really heavy. So that's sort of one of the simplest possibilities. And another
that's the Occam.
sorry.
That's the Occam's razor answer, right?
Yeah.
With
I
the
mean,
simplest possible thing.
yeah, but even
Which
the
I don't. Well,
yeah, but I mean, this is the starting point somewhere, right? It's like it's like you're making a soup. It's like you put in the ingredients. Like, what's the simplest thing? The simplest thing is just like I don't know, salt and water. That's pretty much what
yeah,
WIMPs are.
that's what I think of the WIMP idea. It's like
Yeah.
salt and water.
I mean, there are also, but even the Octum Razor ideas, there's already huge varieties. I mean, the other one is what axions. Like, it can be heavy. Like this is WIMPs are one example that's heavy, or it could be just super duper light, and also really not interacting with us. That's also possible. I think there's a few types, right? There's like axions, gravitinos. Uh, yeah, I'm not too familiar with those. I don't know, Mikey, what do you think?
Yeah, when we were coming up, there was basically two distinct categories. It was either like a particle, meaning like a heavy particle, like a WIMP, and measurable as something that we would recognize as a particle. Like you could actually watch it like hitting stuff and recoiling. And most of those ideas go by the name, as Tim described, as a WIMP. And the other kind of polar opposite side is that it's just this super light thing. It's so light that it doesn't even make sense to think about it as a particle. It just makes sense to think about it as like a blob, like an undulating blob of energy. And there's a lot, whether it has spin 0 or spin 1, there's a lot of different manifestations of this, but that's sort of like the overall picture.
Yeah.
But both of these ideas like rest on the assumption that it's all just made of like one thing,
Yeah.
It very well be made up of like a whole myriad of different things. We know it at least has more than one component because neutrinos we know exist and at least explain part of it.
Yeah, but let's just add that these possibilities have not been ruled out, so they're still in the game, pretty much.
Yeah. Well, WIMPs I think are kind of in trouble.
But still,
I mean,
they're still in
most
the
of the
game.
motivation for believing in them in the first place is kind of out the window.
Yeah. I mean, Octum Razor has been kind of questioned, more or less, in the recent decade. So people don't follow that principle very much anymore. So basically, there's sort of this new
Well,
surgence.
I think it's also worth saying that WIMPs, the reason why WIMPs were even a big idea is because there were certain theories that also predicted that they should exist. So they were like, oh, same thing coming from two different directions must mean something.
Yeah.
But in recent years, that other thing has gone away. So
Yeah, let's not go into the historical details. This could go on for hours, I guess.
Yeah. So we have an audience question, and it's asking, what if there are people who are made of dark matter who can't see us? Question mark for you, Tim.
Yeah, so I think this is the more exotic territory. Like we could try to go into that later, but this possibility, and let me just add that this possibility is also not completely insane. But of course, in terms of physics, in terms of Arctum Razor, meaning using the simplest idea to explain something, it doesn't do anything for us because having extra people doesn't explain any, natural phenomenon. But this sort of general ideas of like, what if there's dark stuff, like just dark, and add some extra stuff in it, dark X. Like this idea comes from the thought that hey, maybe dark matter is not weakly interacting. So far we talk about heavy dark matter, light dark matter, and those are all very weakly interacting. Well, then you can ask the question, well, maybe it's not weakly interacting, and there are two camps for this. One camp is that is that it's just straight up not weakly interacting, and then you scratch your head and you'd be like, well, how come we haven't seen it yet? How come it doesn't light up the sky or whatever? Like, well, how come we haven't detected it yet? But it's still possible. Maybe it's so heavy, there are not so many of them, first of all, so we haven't gotten the chance to see them. Or they actually couldn't reach Earth, because like, they got, I don't know, they got burned out in the atmosphere or something. That's possible. And another possibility is that maybe it doesn't interact with us very much, but dark matter could interact with each other very strongly. So that's another possibility, just like ordinary matter.
Yeah. So, like, can there be dark people just sort of like, dark matter, there's a lot of limits on how invisible it is to us, but the limit on how invisible it is to each other are not that strong at all. So could there be dark people? If someone says no, there can't be. They're usually quoting these limits, or they're usually quoting these results that rule out the possibility. If all of the dark matter is all interacting with itself, then it can't have that much structure. That's true. But if just a tiny part of the dark matter, like as much as we, as small a fraction of the dark matter exists as we do, if that much is interacting with itself, there's almost no bounds. So could there be dark people? Absolutely. There's so much room for that.
Yeah, well, let me clarify that. It's not going to be dark people per se, because first of all, that will require dark chemistry, some kind of atomic structure, but it's going to be nothing like ordinary people. Like, it's not going to be...
If only 4% of the dark matter has dark chemistry, that's not ruled out.
Right, no,
that's all we need.
Yeah, but what I'm saying is, like, you probably cannot imagine the kind of chemistry that goes in. Like, it's not going to be carbon, because it's not going to be carbon, period, right? It's going to be probably some kind of different set of nuclear and atomic physics. I don't even know what that would be like. It could be like just super weird.
It could be very similar, though. It could be that all these sectors down sort of parallel to each other, and we're all these kind of parallel sectors are sitting next to each other that don't communicate with each other because the communication is broken at some high scale.
Yeah, I think one thing you can rule is it cannot be exactly the same. Like, it cannot be exactly the same, but you have a copy, because we have light, and light, if it's really light, it can screw up. It will become dissipative to some extent.
No, it wouldn't be our. I mean, it would be dark light. If it was broken at the gravitational scale, then there would be almost no remnants of that connection at low energies, and they would just be completely next. Like, that's like very speculative, right? I'm talking about Planck scale.
Yeah, I'm not. I don't know if you can get the theory to work out. I don't know. I'm.
No, you can't. We can't make statements about whether or not we can make Planck scale theories work out. I mean, this is just completely like it's not impossible.
Yeah, I would say this requires like us to sit down on a chalkboard and work out some numbers and see.
No,
like,
can't even work this out.
Like, this is the kind of game the kind of game that you can play basically as theoretical physicists.
Yeah.
You're like, hey, give me the rules of the game. Then, let's play ball. Let's see what kind of crazy scenarios we can come up with.
Yeah.
Wow. So it just could be, huh?
There's
That is very strange. That's a lot, man. Wow. Well, so then, what would you say we would need to do to possibly have any chance of finding out what it is? Like, what are all the things with advances in technology or whatever that, is there anything we can do?
If dark matter is really dark, and I actually think that there's a strong possibility that it might be, as we were just alluding to, the physics could work out. Like if the whatever symmetry is broken at such a high scale, then it would be completely dark. Then, yeah, so in the last episode, I think our chances are very bleak.
No, but I think we can still be optimistic, and this is why this is still a research area. I mean, of course, the physicist point of view is that we should be optimistic. So,
Right.
so like you mentioned, we need to design experiments, and maybe ones that are not so expensive, to to think about these different possibilities. So let me give an example. So if dark matter has these very strong interactions, it could form very interesting structure. For example, like dark planets, dark stars, right? And these kind of clumpiness can potentially be detected because these clumpy dark matter can create gravitational fields. And I know some of my colleagues recently have published papers like, if certain types of light signal passes, behind it and toward the Earth. Let's say, imagine we receive some sort of light signal, and those signal passes through these clumpy clumpy dark stuff. Those signal will be changed basically, and so you can see these effects, for example, from quasar signals. These cosmic lighthouse that beams light directly at us, or different types of gravitational lensing. Like it's like light coming to us get bent around by gravity. So this is a new direction in research that we could potentially try to find these substructures of dark matter, like Mikey was mentioning.
Yeah, do you agree with that, Mikey, or
Oh yeah, I mean, I haven't heard about this research, but I'm definitely gonna look it up.
Yeah,
Look it up.
and in fact, I think one can do a bit better, right? Like you imagine astrophysicists studying dark matter. We're pretty much like, I don't know, astroarchaeologists in some sense, because dark matter, you can, to some extent, is one of the oldest things. So we can also think about, Earth being on this dark matter soup for so long. Maybe it could have some interesting effects. So people have tried to find dark matter, like strongly interacting dark matter, maybe getting stuck in some like rocks, like deep. I think in some geological site to see if they're, I forgot, it's like underwater,
I would think it's
underground.
not.
It's some kind of clay rock, and they can see, hey, the dark matter gets stuck here at some time, right? And you can have these crazy experiments where, like, one of my colleagues at Berkeley had a paper on, like, imagine dark matter, let's say strongly interacting but very large, like macroscopic, like I don't know, like a centimeter large. If it happens to hit something in water, it could trigger it could trigger like a sound wave signal. You might hear like a click from underwater. So potentially they propose that you could put like some sonar detector in the ocean to detect them, or maybe the military can work on that. So I'm just saying these are some of the crazier possibilities for dark matter detection. And the thing is, if nobody had thought of them, like you just wouldn't know. Like it could be there, and you just don't know. You just couldn't see it because you haven't thought of it ever, right?
yeah. Wow. So is that the craziest one, or is there like an even crazier
They're crazy.
experiment?
They're crazier ones, right? We definitely need to talk about the dinosaurs.
Oh yeah. Why don't we quickly mention that as wrapping up as we're wrapping up?
Yeah, maybe Mikey, you're such a fan of this. I'll let you explain that a bit.
I'm not. No, I mean, it's a crazy idea. I mean, I feel like it was a publicity stunt, but there's this idea. I don't know if it falls kind of conspiracy theory. I mean, it's kind of this astronomical conspiracy theorist. um, there's this idea that there could be some planet outside of our solar system that could trigger these very long cyclical asteroid storms. So you could imagine that there's like a planet, maybe very far outside of our solar system, that enters once every a million years, and when it does, it might send a barrage of asteroids or rocks in our direction that trigger mass extinctions. Because in this observation that if you look at the mass extinctions, they kind of follow this million-year cycle, and if you assume that that's true, you can sort of calculate the kind of weight, mass it would have to have as a function of the kind of orbit. And what I guess someone published a paper that dark matter could be related to this in some way.
Yeah. Wait, is that the content of the Lisa Randall's paper?
Oh yeah, now I'm totally forgetting now how the dark matter is supposed to trigger this. But
Yeah. Are these dark matter planets basically, or something like that?
no, I don't think so. That's kind of confused because it's not a hard object. But I guess.
Yeah. Well, I think the crux is that a small fraction of dark matter might have formed a disk.
It could be large.
Yeah. So and then somehow it aligns with our galaxy, and then somehow the gravitational pull for dark matter will attract asteroids to make it more likely that asteroid will hit Earth and wipe out dinosaurs, and maybe us in the future. But that's one of the more one of the more, I don't know, publicized idea, and it's since been ruled out, I think, by some of my colleagues in Berkeley. So it probably doesn't work. It doesn't work.
As much as I call it a publicity stunt, I'm not gonna lie. Like that kind of like experiment is kind of opened up my imagination and curiosity to this idea of
Yeah.
structure and dark matter.
Yeah. And let's just go on this destruction spree a little bit. Like there have been many papers that says also the kind of the kind of dark matter could collect potentially in stars and white dwarfs, like really dense stars, neutron stars, and potentially once you collect large enough amount, the gravity from dark matter could could pretty much destroy the star. It could form a black hole, or there's so much gravity pull it can cause an explosion. So dark matter could be no joke. It could be quite destructive. in some particular theories, but
wow, that sounds intense. Yeah. So I think anything else you guys want to add before we call it quits?
yeah, I just want to add that dark matter, the physics of dark matter, the physics of dark matter model building, it's a very much blossoming field, and this is pretty much an area where a theoretical physicist's imagination runs wild. But at the same time, to some extent, it's sort of justified, right? Because we really just don't know very much about dark matter, so we should really just open up our minds and let our imaginations run, because why not, right? Like, because we don't know what dark matter is, and there are many things it could be. So.
Anything else you want to add, Mikey?
Yeah, sure. Just to add quickly, I just think it's such a shame that when I see my Google News headlines, I see so much kind of fake controversy. Does dark matter exist? Does it not? There's so many more interesting questions once you accept the fact that it exists on what it could be, and we talked about a lot of them here. And it's good to be skeptical of scientific results. I agree with that, right? But I feel like it's gotten to be a little bit too much work. Look at the evidence. It's very contrarian and kind of at this point restrictive to be so firm in that and not firm in the idea that there's no dark matter, but being unwilling to accept the possibilities, you know.
Yeah. Well said. Well said. So with that, I want to thank everybody for joining us, and we'll see you all next week.
Yeah, thanks everybody. See you
Thanks.
all.
Yep.
Bye.
Yeah.